Hi, welcome to this episode of the Educate podcast. In this episode, I speak to Justin Germushiys. Justin is the founder of Germushiys. He's an insatiable generalist who weaves solutions using strands from learning design, behavioral design, data analytics, AI, and more. He has a particular interest in using AI to supplement and enhance human reasoning. Between projects, you'll find Justin reading P.G. Wodehouse and eating chocolate biscuits. This is a really fascinating discussion where we go really quite deep into the arts of prompt engineering and some of the psychology that sits behind how we interact with AI on a day-to-day basis. Fascinating and really one that I hope you enjoy. Justin, hi. Thank you so much for coming on to the podcast. I really, really appreciate it. I think you're definitely someone right now who's really in the thick of it when it comes to prompt engineering and working with AI models and training AI models. So I think I want to get quite sort of practical and really talk about the some of the techniques that you would recommend for particularly people who are beginning working with AI at the same time. But just before we do that, I'm really keen to understand how you managed to get into AI in the first place. What was some of the background behind you becoming interested in working with artificial intelligence?
Good, Darren. Firstly, thanks for having me. It's a pleasure to be here. And to answer your question, I think this story goes back about 12 years. I was doing a master's degree in cognitive psychology, and my supervisor at the time directed me towards some of Andy Clark and David Chalmers' work. So I read Supersizing the Mind and Natural Born Cyborgs. And that's how I got really, really interested in the idea of the extended mind hypothesis. And I've always been interested, for as long as I can remember, in or fascinated by how people think. What are the cognitive processes? So at the time I was exploring sort of creating a taxonomy for operations of thought. That was really what I was focusing on at the time. In the end, I didn't finish the master's, but I kind of got sidetracked by an entrepreneurial endeavor at the time. And I thought, wouldn't it be cool if we could use technology to supplement these cognitive processes? Normally, it takes people years of dedicated practice and discipline to develop certain cognitive abilities, critical thinking, metacognitive abilities, ability to monitor and regulate their own thinking. So I kind of went off on this tangent where I started exploring the technologies available at the time to say, okay, what could we do to supplement critical thinking, the ability to identify rhetorical devices, cognitive biases, and logical fallacies in language and text? So that was my first bit of the first spark. And I came up with this idea of using technology to find those things in the text that people were engaging with.
Okay, yeah.
But at the time, I couldn't code, had no technical background, and I thought, okay, you have to be some kind of a genius to engage with technology. But after spending about 12 months looking for somebody who could do the work for me, I just decided, you know what, let me give it a bash. And so I started learning to code, and then I got seriously into natural language processing. At the time, there were interesting early stage machine learning models, things using linear regression, decision trees, those sorts of things. So a lot of my early interaction with AI was then. So of course the technology. Yeah, sorry, go ahead.
I know. So I was going to ask, you may well be going on to say this. So how did you, that's really interesting. So actually in many respects, it's slightly back to front and that you came across a problem and that you saw technology as a solution. So I guess the natural question that follows on from that is how did you find your kind of understanding of programming and getting into sort of natural language processing help you to unlock that problem?
So given my background in psychology, philosophy, and language, those were my majors, I try to tackle it from that perspective. Essentially, what I was trying to do is use technology to pick out linguistic features in text, indicators that people were comparing things, that they were hedging, what words signified that an argument was being developed, those sorts of things. So from that perspective, what I was trying to build was an algorithm that could identify linguistic indicators. I hit a wall at the time because the technology at that point wasn't good at picking up the semantic features, things that weren't explicitly stated. So we often, a lot of the meaning that we communicate is unstated. And so we do have to look at context and read subtext, read between the lines, and the technology at that point just wasn't there. So I kind of parked that and went into learning experience design after that, where I was for many, many years. And interestingly enough, for most of that time, I worked on building conversational learning. That was how the learning was delivered to our clients. So in doing that, I kind of picked up quite a lot about how to build systems that communicate naturally with people. So that was really, really good. And as I continued in that vein, I tried to bring technology, and as AI developed, I tried to bring that into my work. So over the years, I built things like storyboard analysis tools and authoring support. So for instance, I could pick up patterns in the way we needed to write learning material and use technology to automate some of that, and also to support QA in a lot of those things. So I've been thinking about these problems for the last 10 or 12 years. And eventually towards the end of that, I moved into being head of learning analytics and research. And at that point, I was really trying to bring AI at that point into learning design. I think at that point, that was when transformer models started coming onto the stage. We were working with things like BERT and some other models that were developed by Facebook and Google. And again, like compared to what we have today, those were pretty simple, but you could train them to do simple tasks. And at that point, AI, or at least natural language processing AI models, were very much task specific. You had this model for semantic, for sentiment analysis, and this one for extractive summarization, and then that one for question answering. So you had to blend all of these models together.
Yeah.
So at that point, I decided that I wanted to leave learning design and start building my own consultancy, which is sort of a blend of my background and my passions: learning design, behavioral design, and then, of course, the one that I started 12 years ago, AI reasoning support. So that's where I've been busy ever since. So also, I think for a lot of people, ChatGPT was the starting point, the point at which they became aware of AI. But before that, OpenAI, for instance, had GPT-3, and before that, GPT-2. So I've been playing with those models all along. And what has been very interesting to see is just how much more intuitive they've become and multi-purpose they've become. So I think that's roughly a summary of how I got into this.
So obviously, as I said, you've slightly done it in some respects back to front from how a lot of people, because a lot of people will start to program and understand AI and then will maybe come across problems that they want to find solutions for. And there might be a lot of people listening here who are approaching it in the same way. So you know, like for myself, as like you, I've very much been a humanities and language specialist with an English drama, philosophy, theory of knowledge. And now I'm only really starting to become interested in programming and looking at how to work with Python. Is there any advice that you might give actually to people like me who genuinely want to understand some of the mechanics behind solving these problems, but genuinely have no idea where to start? So I mean, how did you start to learn to work, you know, with the language of these computer systems?
That's an interesting question. Like with most learning, it's not a straight line. It's this reciprocal back and forth. I think, and we all agree, problem-based learning is a really, really good way to help people learn. You start with something you care about, and then you start pulling in resources, and you start to identify gaps in your knowledge and your skills, and you just start fitting the puzzle pieces in. So typically, it doesn't hurt to start, well, it didn't hurt me to start with some introductory course on Python, on natural language processing, just to get some of the key concepts down. But after you finish those courses, you still can't do anything. So then it's just, you just keep going until things start making sense. You have an idea, and you spend the next 3 or 4 days saying, can I make this idea a reality? And as you go through that process, things become clearer. But having said that, with the advent of AI, that process is a lot quicker and simpler.
Yeah.
Because there's a concept in programming training called desert first. And the idea is you expose people to wonderful, amazing outcomes that they can achieve solely to get them hooked.
Yeah.
And after that, they have more appetite for the slog work. But with AI, what's great is it can generate code very, very quickly. It can annotate that code. It can explain it to you in natural language. You're not working with abstruse documentation that doesn't make any sense, and you're spending more time just trying to interpret the words than you do actually learning the skill. And so I think that there's quite a lot of benefit for people coming into it right now if they just realize that AI can be an amazing tutor and support tool.
Yeah.
And like all kinds of master apprenticeship relationships, it can do a lot of the heavy lifting at first. And as you go through it and you become exposed to it and you start looking at good practices, you start to pick up those skills. You end up picking up an intuition for that. But that's coding. In terms of AI, what I would highly recommend is that people don't get stuck too much on recipes. AI is a completely different beast. It's not like coding. It is more like language. And so I often say to people that if you're looking for somebody who's going to be good with AI, find a philosopher.
Yeah.
Because it's less about rules and algorithms and more about clarifying concepts, being very, very clear on what you're trying to communicate, and being able to break complex ideas down into smaller parts that AI can handle.
I think that's a really...
And I think teachers are good. I mean, that's what they do, right?
Yeah.
They take complex ideas and they try to present it in a way that is understandable to others, and they make implicit knowledge explicit. So I think teachers are very well placed to do amazing things with AI.
I think that's very, that's a very astute observation. The more I look at AI, the more I understand working and speaking with AI and having conversations with AI, the more I can see how it's as if all of human psychology has been encoded in AI, because human psychology is, in essence, underpinned with language. You know, we think in language, we speak in language, we communicate, we interface. Everything is so wrapped up in not just spoken, but also non-verbal communication, that our tone of voice, it's all wrapped up. And so I think that the more I work with AI, the more I understand that, yes, there are certain rules that you need to follow, and which we can maybe come on to some of the kind of, not necessarily the recipe, but maybe some of the ingredients to good prompting. But ultimately what we're dealing with is a new form of psychology, that we're actually dealing with a new intelligence that we have to handle in a certain way. So a really good example, the AI seem to really like to be flattered. You know, if you begin a prompt, you are a world-class X, Y, or Z. Again, maybe I'm wrong here. It'd be interesting to get your perspective, but I always get a sense that it seems to almost slightly raise its game. So I think that dealing with the notion of AI is almost having its own psyche, and ChatGPT feels like a different personality to Claude, and certainly different to Pi, because Pi's this kind of crazy PhD. I'm just quite keen. So in your dealings with it, obviously with your background in psychology, have you noticed that? Have you noticed that it almost feels like you're dealing with different psychological entities when you're working with these different AIs?
simple answer is yes. But there is nuance. Do I think that they have inherent personalities? I think to some extent yes, and to some extent no.
Yeah.
If it depends on the quality and nature of the training data. So one thing's for sure is that OpenAI's model and Claude's models and Inflection, they're trained differently. They have slightly different architectures. And although they have a lot of the same data sets in common, they're also using very different data sets. So for instance, Claude has Anthropic has really pioneered the idea of constitutional AI.
Mm-hmm.
So they take an entire value system. I think their constitution includes things from the Declaration of Human Rights and Apple's user policies and you name it. They have this really long constitution. So as they've been fine-tuning their models through successive training rounds, they've been trying to steer the responses to align with that. I think OpenAI has done some of that, but not in the same way that Claude has. And from what I know about Inflection AI's Pi, they use a very, very different architecture entirely. But also the purpose of Pi is to be more like a coach-like character.
Yeah.
Through questioning, reflection, paraphrasing, it resists giving you answers, but it will if pushed. So in that regard, they've been fine-tuned to do things slightly differently. And so in that regard, they do have different personalities. But that said, they're also, at least Claude and the GPT series of models, they've been trained to be steerable, which means if you tell it to assume another persona or another character, it will.
Yeah.
And it will very much emulate that. Also, the thing to know about these models is behind the scenes, they do have system messages where they've already just described to it what personality to adopt. So, for example, if you're using the API, you'll see that by default it says, you are a helpful and encouraging assistant.
Yeah.
That is almost plugged in by default, but you can change that if you're working with the system message or even directly in the prompt itself. If you ask it to exhibit a different personality, it will. So, as I said, to some extent, it has tendencies that are baked in, but the explicit personality that you experience is often just an instruction prompt under the hood that you can change.
Let's kind of dig into that now, and let's just take those three models that you referenced: so ChatGPT, Claude, and Pi, because those, I think, again, I'm not using Bard very much. I just find it hallucinates, and it's just I don't like the UI. I don't like the way it responds to me. I just find it it's just, for me, I don't just, for whatever reason, I just don't get on with it. And I think a lot of people that I'm speaking to are feeling broadly the same. I just hope Gemini has to be better. But if we just take ChatGPT and then Claude and then Pi, when it comes to actually prompting them and working with them, how do you differ in the way in which you'll work? Well, first of all, how do you differ in terms of workflow? I mean, if you use all three, maybe you don't. I'm not sure, but I said use all three. Okay, so how do you use each of those three AIs, and then how are you prompting them to get the best out of them?
Right. So right off the bat, I don't make that much of a distinction between ChatGPT and Claude. I find that they can both do the same sorts of things. I think that there is near capability parity between the two. They do differ in terms of their defaults, and certainly Claude has a much bigger context window, which is useful for some things, but not for others. So the difference for me is not so much in the prompting between Claude and ChatGPT. The biggest differentiator for me is the context window.
In terms of, sorry, just pause you there. Can you explain what you mean by context window? So that, because I think some people get confused by, we sometimes trade that for memory, but it's not quite the same as memory. So can you maybe just give a sort of a layperson's kind of understanding as to what a context window is and why Claude's Why is Claude so much bigger, and why is that potentially beneficial?
Sure. So essentially, just trying to find the least technical way of putting this, think of a model as being able to handle one interaction. I can say something and it can respond. Mm-hmm. That model has no memory of its own. Any appearance of memory is an outside database that is being stored and then fed back in each round. So the model is not learning as you're having conversation. It is what it is, and it keeps pulling information in as needed. So think of it as you say something and it responds. Mm-hmm. The context window is how much I can say plus how many words it can generate in response before the model reaches capacity.
Right.
Before it's a limit.
Yeah.
So in the case of earlier models, the capacity was 2,000 tokens. It's about 75% of your word count. Mm-hmm. So let's say you have 10,000 words or 10,000 tokens, you're looking at about 7,500 words.
Yeah.
So let's say the context window is 2,000 tokens. That means I can say something that uses 1,000 words, and the model can generate 1,000 words in response, and then it hits its limit.
Got it.
If it needed to generate more, it would just cut off mid-sentence and wouldn't generate any more. So context size is really, really important, because the larger the context size, the more information the model can process in a single round. I think at the moment, if you're looking at OpenAI's offering, they have 8,000 token context windows, 16,000. I think the biggest is 32,000. With Claude, it's 100,000. So you can almost imagine you can put in a 50,000 word book, and it can generate 50,000 more words in response to whatever you've asked it to do.
Yeah.
Whereas ChatGPT, you have to break the book up into chunks and have it do it in a series of separate steps.
Is there a couple of questions following on from that? And these are questions which have actually come up in sort of various training sessions I've been doing. And I think I know the answer, but I'm not quite sure whether I'm getting it right or not. So if I'm using Claude, for example, and I'm uploading a book into with the little paperclip icon, and let's say it's 50,000 words as a book, is that immediately 50,000 words of the context window gone? Or does it kind of read that, and then I've still got the 75,000 words that I can then use to kind of go backwards and forwards?
It's 50,000 words gone.
Okay. So it doesn't matter whether you dump the 50,000 words directly into the or whether you upload it actually, you've got...
it's the same thing.
Fine.
It just looks different. So the UI presents it differently. If you're exceeding that context window, so let's say you put in 200,000 words, not 100,000 words, what it's going to do is it's going to split it up into chunks. And behind the scenes, what it will do is it will try to find only the relevant bits that are important for your current query or instruction, and only insert those into the context. So in the background, it's selecting chunks and leaving out irrelevant things.
So if I'm, this is really interesting. So if let's say, for example, I've got a novel and it's 100,000 words, and it's only, I upload it into Claude as a TXT file, and it's only maybe, I don't know, 400 kilobytes, and I've got 10 megabytes. I could potentially put a lot more than 100,000 words in. And what Claude is going to do in the background is just pull out the sort of the relevant information. Is there not a danger that it's going to miss stuff?
Absolutely. And so there's an enormous amount of research and engineering around these background processes to make sure that it is pulling the most relevant stuff out. It actually does a pretty good job. You know, currently there are a lot of services popping up where people are saying, use a service to chat with your PDF. And that's essentially what it's doing. It's basically just carving it up into small chunks of maybe 1,000, 2,000 words. And then what it does is there's a separate model that says, okay, based on what you've asked, let's run through all of the chunks that are in the database, and let's just find the ones that based on the model's training, it's identified as being relevant or containing the necessary information. So from the end user's perspective, it feels like a perfectly fluent, seamless experience. In fact, when you're working with ChatGPT, you can keep having a conversation for days, and it feels like it's always remembering what you said last Tuesday. But all that it's doing is it's saying, okay, based on what you're saying now, of all the things we've spoken about, pick the top 10 things that are most likely relevant to what we're talking about now. And that just pulls it back in and pops that back into your prompt. So what you're typing into the prompt isn't what's being sent to the model. It's what you've typed plus this pasted in context that's happening under the hood.
There's an enormous potential benefit as that develops further if I just take education as one use case, because the more an AI can remember, I'm using the term remember, it's not quite right to use that, but the more it's able to store in its database the data that we've inputted and the learning it's taken from that, the machine learning or whatever, however it works in the background, this black box that no one, not even OpenAI scientists really know about. Actually, I understand. The more actually that there's a potential for it to be of enormous benefit for us as we learn, because we can see, and I think a lot of us are talking about this, that every person, every child will have its own AI mentor, AI bot that will learn and grow and develop. How far away do you think we are? And again, we don't know for sure, it's all conjecture, but from the point at which we genuinely will have AIs with a big enough context window to actually genuinely learn and remember who we are and our learning habits and where we are in our learning for various subjects, and can they be there to guide us and support us, and who will just never forget for years and years and years? I mean, can you imagine a time in the near future where we might have that?
Yeah, I think that the time is now. So the context window is not a precondition. As I said, there are techniques where, don't think of one model instance as being equivalent to an entire human mind. You can take 10 model instances. So let's take a model instance as I give ChatGPT an instruction and it gives me an output. Mm-hmm. That's just, think of that as one part of a brain. And similarly to our brains, our memories are stored in a distributed way, and then they're retrieved and woven back together and then brought into consciousness in that way. If we think of AI as not being just the model itself, but the model connected to tools, other models, databases, the internet, we think of that collectively as the AI we're interacting with. We can design systems that can already perform what you've just described. So, for example, there are very popular vector stores. I'm not going to go into detail there. It's just anybody who's interested, just look up or ask ChatGPT to explain vector store like your files, and then you're good to go there. But there are services that allow you to store literally terabytes of information that use very interesting intermediate machine learning processes like clustering techniques and so on to pull the relevant information. So already your entire life biography with minute detail could be stored in there and retrieved as relevant to inform any task that you give AI to do. And certainly I would say GPT-4 is already at a point where it can be completely personalized if you're not too concerned about the data privacy issue, which is a different concern, but we're already getting there. And with open source models, we're already at a point where these techniques are revolutionizing how we interact with AI. I think what we're waiting for is just more tools to catch up. But it's certainly technically feasible.
Okay. So what you're basically saying is that we are now in the position where we can marshal the various resources to create an artificial intelligence entity which works alongside us, which can actually genuinely support us. What what is that going to do to the education? And again, I know I want to come back to how the sort of practicalities of how you use these AI. I think that's really interesting in itself, but just feels like we're going in a slightly different direction, which I also think is really, really fascinating. How is that, do you think, going to change our education system and our schools and the notion of what the teacher is and who the teacher is? Because I think that has massive implications.
It's a big question. So I think the best way for me to tackle it is by focusing on something very, very simple and then emphasizing the implications. Just as an intuition pump to help us imagine what might be possible. I don't think that it's useful to think of the future of education or the future of learning as being what we've seen to date plus AI slapped on top just to make it more efficient. I think what we're seeing is quite a shift in the foundations of education, what it means to be human, what it means to learn, what it means to work with knowledge. So just to come back to this, a simple example, and I try to tell everybody I meet about this, but it seems so simple, so it's almost as though people don't take it seriously enough. You can go to Claude or GPT 3.5 or 4 or even Bard at this point in time, and you can put in a complicated concept. Let's say it's activism or perplexity or whatever word or concept or explanation. And you can say, explain it like I'm 5.
Mm-hmm.
And it will pop out an explanation that at the very least gives you a foothold into that concept. So now, even if you are, say, 10, and you've put in a concept that traditionally you would have only been able to understand 4, 5, 6 years in the future, you can now get that foothold much, much earlier in your education. For many kids, the way that a teacher explains is not necessarily the way that they need something explained.
Yeah.
And so just in terms of supplementing explanations and helping them construct a web of conceptual understanding, I think that can happen a lot quicker for children in education. And that's just one thing. That's one thing. Any teacher can go out today and say to their students, here's a little interface. Either you can use one that you've built yourself or connect to Bing or Bard or whatever's free or accessible and say, plug in quantum entanglement and explain it like I'm 5. And then give that child 5 or 10 minutes to just identify the next word they don't understand. Plug it in. You can even take the formula for photosynthesis, plug it in, and say, explain it like I'm 5. Like that one thing has immense potential. And that's just one thing. So when we start thinking about the future and we start looking at all the things that AI can do, it's really beyond our current ability to imagine. That's why I often say that what we need more than engineers are science fiction writers. People who can almost peer beyond the next horizon and say, okay, this is the reality we're going to be engaging with. So often I say to people, look, if you want to start preparing your mind for working with AI, watch more Star Trek. So that's the one thing. The other thing is I think that in terms of how we engage with knowledge is going to change significantly. Right now, we think of AI as a tool that we command.
Yeah.
So we give it an instruction or a question, but there's an enormous amount of research going into autonomous AI. AI, when given a broad goal, can construct sub-goals and make observations, have thoughts about that, self-evaluations, complex reasoning processes to formulate what it needs to do next. So it doesn't necessarily require a human being to prompt at every step of the way.
Yeah.
So at least early on in our relationship with chatbots, I think that what we're going to end up with is a bit of a feedback loop. We will be prompted as much by AI as we prompt AI. And that's a matter for design.
Okay.
How do we use good behavioral science principles and ethical behavioral science principles to design AI systems that prompt people to do things in a safe, beneficial way. So let's say let's assume we're 6 months in the future, we have multimodal AI. It's not just text-based, it has computer vision plugged in. A person or a child walks into a situation and they're not just relying on their own perception or observations of the situation. AI is also scanning the scene, making observations, and based on its design, saying, hey, notice this. Just a slight nudge. And then combine that with certain techniques like explain it like I'm 5, you suddenly have the capacity to build observational skills, reasoning skills, a depth of understanding that wasn't possible before. So we do need to think about that feedback loop. And as the person becomes more sophisticated in that relationship, they contribute more to that interaction. They can start directing it in more creative and productive ways. So it's almost like level 1, you're being pulled along by AI, whereas sort of like level 5 is this true integration where you don't know where your mind ends and AI begins, sort of thing.
And that's absolutely where, Andy Clark comes in, and James Lovelock with this kind of notion of sort of novacine that he talks about, that actually we will soon reach a point with the sort of what I guess is you referenced earlier on, this notion of the extended mind, where essentially, and we're kind of almost there now, just the fact we have our mobile devices, that we would really struggle without these devices, that they become part of our physical reality, not just things that we pick up and put text into, but actually they are part of our mind. So the more that we have AI, almost it's as if we move from a situation where we are interfacing in one direction with the device. I look at my phone and I tap messages into it, etc., or maybe I read stuff, to actually that becoming an observing entity. That we will, if with computer vision, that we will have an AI that will also be observing the world around us, and that will be feeding back to us, and that will be prompting us and nudging us, as you've said. So it's almost like we will soon move to a point where it's not just our eyes that are seeing the world, it's the AI's eyes that are seeing the world. It's not just our minds that are processing what we're seeing, it's the AI also processing what it's seeing. And it's that interface between the developing consciousness, if you like, of the AI and our developing consciousness, and the way in which we don't have to have a neural implant in order for that to occur, because actually it can happen at the point of the interaction between us and the AI that can create that synergy that maybe that will possibly, and I'm hoping it will, make us a lot more than this is the optimist in me, that it gives us the opportunity to be a lot more than we are if it's just our own minds and our own eyes.
So even before AI, there was this concept in the cognitive sciences called transactive memory. And it's this idea which also underpins the idea of organizational memory. So even if you're in a marriage, for example, I've been married for more than a decade, I know what my wife knows. So I know I don't need to remember it. So, and similarly, vice versa. So there are different areas where we're offloading memories to each other.
Yeah.
And you find for people who've been together for, say, 50, 60 years, and they lose a spouse, it is like losing a really big part of their mind.
Yes.
Who they are.
Yes.
And as AIs start to become more human, but also have capacities that far exceed anything that any human being will ever be capable of, that extension becomes quite mind-boggling. That's why I say that I remember watching a sci-fi show recently. What was it called? Peripheral. Yes. And there's this, spoiler alert, that there's a scene in the future where people are already AI is completely integrated in how they think about, perceive, understand, filter the world.
Yeah.
And the one character looks at chess and says something along the lines of, it would have been nice to have experienced playing chess without AI, because already like they just look at the chessboard and the moves are obvious.
Yeah.
And I just thought that was a really good illustration of what a society might look like when all human beings have AI supplementing but augmenting. And we spoke a bit about computer vision, but it doesn't stop there. You can plug in temperature readings, biometric information, heart rate, blood pressure. You can plug in data from a seismograph. You can have infrared spectrum detection, all sorts of additional sensors attached, feeding AI's interpretation of a situation, filtering that, and then presenting it to you in a way that is accessible to you. I mean, already if you wear infrared goggles, all it does is it basically converts wavelengths you can't see into wavelengths you can see. So there's this point of conversion that allows you to access information you wouldn't have been able to access otherwise, or perceive things you wouldn't have been able to perceive. So I think that from that perspective, it's very interesting. But this is delving, sort of definitely getting well into sci-fi territory. I'd like to come back to prompting and then maybe start with some practical advice.
Yeah.
That's okay.
Yeah, no, I think you're right. Look, I think that this is the kind of discussion that we could go really quite far down the rabbit hole, because we can start talking about, well, at what point do we lose track of who we are as individuals? Has that been going on a long time anyway? Because actually this extended mind we've had for as long as we've had tools to extend our abilities. So I think you're right. So let's just go back, let's wind back a little bit to the sort of more practical focus and think about, the AIs that you're using, and we mentioned ChatGPT and Claude and Pi. Any advice that you've got to give to people as to, the best ways in which they can use these three? And I'm going to use the term personality simply because I think for me it's quite a good shorthand to think about the capabilities of each of the systems.
Sure.
How can you work with the sort of psychology and the capabilities of each of these systems in the most optimal way?
So I'm going to put Pi to one side because it's not quite as information centric as the other two. So I'll park that for the moment. When I talk to people about starting to prompt, I introduce a series of distinctions. So I make a distinction between a recipe, a technique, and a tactic. Recipes are set templates that you just plug in. So basically what you're seeing on LinkedIn when somebody says, take this prompt, plug it in, and it's going to generate your best learning outcomes. I have a serious problem with that, and I'll get to why that is in a minute. The best place to start is to recognize that there are certain capabilities that AI has, and then to unpack what those are. And I call those tactics. They're little goals. They're tasks. So, for instance, I can extract information. I can organize information. I can convert information from one form to another. I can translate. I can analyze, decompose things into their component parts. I can synthesize. This is what most people think about when they think about generative. Like, write me a poem. It's synthesizing, right? So each of these are what I call tactics. And I put together a nice framework I call ORCTAs that makes it easy to understand what the categories of tactics are. And I have a video on YouTube. People can go and watch it. And once you understand that, you understand that you can actually compose these tactics. So, for instance, I can extract something from text, and then let's say I have a story and it has the name of 5 characters, and I can say, extract the name of the 5 characters mentioned in the piece of text that I've just pasted above. And it will pull out those 5 names. So that's an extraction task. And then I can say, well, organize them in alphabetical order. And then it will organize them in alphabetical order. Then I can say, well, now write a story where the appearance of the character happens in the sequence that they are in this list. So there's a synthesizing operation. What I'm trying to illustrate is that once you've thought about each of the tactics, your ability to work with AI becomes composable. It's almost like language. You learn a whole lot of words, a whole bunch of verbs, and you can say things that have never been said in the history of the world. You can compose language to express an infinite number of things. And that's similar. When you start to learn the fundamental tactics, you have a deeper understanding of what the prompt is doing. You have the vocabulary to think about that. The next level up is what I call techniques. Techniques are different ways to implement a tactic. So let's say I wanted to extract 5 names from a story. I could give it an instruction, simply say, extract the 5 names of the characters mentioned. Alternatively, I could say, ask a question. What were the 5 names of the characters in the story? I could give it an example where I've taken one story, extracted names, and I'll give it a new story, and it infers from the example to pull out the 5 names. I can create a completion prompt. I can say, the 5 names of the people in the story are, and it will do this. Each of those different techniques will achieve exactly the same result. And so often, your choice of technique has more to do with what is comfortable for you as the communicator, and less to do with the model's capabilities or limits. Now, earlier models were very sensitive to exactly which technique you used and how you phrased things and how you ordered things. And a lot of that, I think, has become a bit of a vestige that we carry over into more sophisticated models. The more sophisticated a model is, the more steerable it becomes. So GPT-4, for example, does a much better job of interpreting my intent, irrespective of how I've written the prompt. What is important, more than the technique that I'm using, is how I've composed the instruction, how I've put those tactics together to get a task done. So, although it is true that for more complex prompts, there are some techniques that are incredibly wonderful, as time goes by, you can choose whether you want to use this technique or that technique. There will be much of a muchness. A recipe is just sort of a collection of techniques and tactics that performs well at doing a job right now, and you basically just package it and you give it to somebody else as a recipe. The problem with recipes right now is that they don't work the same across different models. So if I have a recipe that works with GPT-4 and I plug it into Claude, it's not going to do the same.
Yeah.
So in GPT-4, I might not have needed to specify that I wanted to put the information in a table. It'll just do that automatically.
Yeah.
I put it into Claude. Claude doesn't make the same assumption, so I have to specify it. So recipes can break across models, and also when models are upgraded, they break. So anybody who relies entirely on recipes will find that it will stop serving them. And also, as time goes by, more and more errors might creep in. So they can't rely on that recipe. If you are going to use recipes, you need maintenance. Somebody who understands tactics and techniques, who can say, you know what, this thing I had to specify before, I don't have to specify it now. This thing I didn't have to specify here, but I have to specify it there. So that's what's quite important.
That's a really, really interesting way of putting it. So it's almost a little bit like when we talk about learning a language, it's the difference between, what we say learning restaurant French, where we just learn some set phrases and they work fine in the restaurant, but we can't take them into an office, because if we use restaurant French in an office, people look at us like, what are you talking about? So actually we need to learn grammar, vocabulary. We need to actually learn it's the literacy. So when we talk about AI literacy, this is kind of what we're talking about here. We need to really understand the foundations, the actual nuts and bolts of the language. So when we're prompting AI, and then actually we can tweak them compared to, depending on the model that we have. But ultimately, the foundations are the same, and they're not going to change.
Absolutely. So the tactics will always remain the same tactics. In fact, if a human being learns those tactics and they learn to articulate their reasoning process in that way, they become better thinkers.
Yeah.
Because they can be a lot more intentional about the different components that they're bringing into their thinking. The more that AI is good at interpreting what most people mean when they say something. So it's going to be very, very good at producing good results on very vague and ambiguous statements. But the moment you don't mean what is generally meant, the moment you don't have in mind what a million other people have in mind, it's at that point that that strategy for prompting breaks down.
Yeah.
And the issue is that by default, AI, if you say, give me a list of 5 important learning principles, it will do that. But it's going to give you that information based on what we currently think the best advice is. And it will only give you that advice if the answer existed. But when you're using AI to solve novel problems, that answer never existed in its training set. So at this point, you actually need to focus on getting the AI to reason well, and to reason in unconventional ways. So that's been a focus for my research and for my work, is how do we get AI to reason? And this is another very important distinction that I would like anybody listening to this podcast to understand quite well, is that there are 2 broad ways of working with AI. One is an outcomes-based approach. So essentially you give it an input, the model does its magic in the middle, it's a black box, and it gives you an output. So if I say, write me a rap song about Christmas lunch, it's going to produce something that most people are impressed by. But you have no control over what it does in the middle. You don't know what it does, what it's done, you don't know where it's made its mistake. So outcomes-based prompting is quite a dangerous way to work with AI if you want it to be steerable, transparent, and reliable. A different approach is process-based prompting. So there's almost a step or a capability that has nothing to do with the prompting itself, but it has to do with how do you understand the process it needs to follow. To give you an example, one thing that large language models have struggled with is stand-up comedy. And I tried for weeks or months to get AI to do observational stand-up bits. And eventually what I did is I asked it to generate a world-class comedian's explanation in an interview of the precise thinking process they go through when creating a bit. So essentially it created this really elaborate thinking process. It's like coming up with an idea, critically evaluating the idea, replacing the idea, imagining what the audience is going to think, how it's going to land. And it ended up generating probably a good few thousand words of process description. And then I simply said, okay, now apply that to coffee, apply that to linen. And off the back of that, it made some amazing observations about coffee, and it came up with incredible metaphors, and it actually put together really funny stand-up, at least funny to me. It's of course humor is subjective, but it illustrates the point that you can enable AI to perform a task that it wouldn't have been able to do if you took an outcomes-based approach. But if you were good enough at decomposing the process and defining the terms that you wanted it to use, then it can do the task. So quite often, the limits that people say they find with AI is actually more of a limit in the clarity of the process they've included in their prompt. I don't know if that's...
Yeah, no, it does absolutely. Makes perfect sense, actually. It's a really interesting way of putting it. Can you maybe, just so reach the kind of the last part of this discussion, I think if we just go back to the kind of the practical nature of what you've just said, how can, let's stick with teaching and educators. How can an educator apply that process? What are the kind of the practical ways that they can deploy that, which can actually really help them, I don't know, plan lessons or create resources or whatever it is that teachers are using AI for at the moment? Because I think what you've just said is absolutely right. And I'm guilty of doing this as well. You know, I wanted to write a scheme of work. It's very much an outcomes-based approach. How can we move more towards a process-based approach to actually help facilitate better resourcing, better lesson planning, better assessment of student work, for example?
Right. So I've actually been working with some learning designers recently, and so I have had to formulate what a good workflow is for this.
Yeah.
Many people doing lesson plans or designing a learning experience, they don't necessarily have that depth of theoretical understanding necessarily, or there are perspectives they may not be aware of, or there are, as human beings, we're quite good at following processes, but a lot of those steps are implicit or tacit.
Mm-hmm.
So we don't even know. If you ask somebody, like, what process do you follow to do this? They'll say, like, the 5 big steps, but they won't be aware of the minutiae of that, and they won't be able to express that. Interestingly enough, AI is actually very good at unpacking that. So as part of a workflow, I might, instead of say, create the lesson plan, I say, what are 5 different processes I could use for creating a lesson plan? So step 1.
Right.
So I'm getting it to identify different processes.
Yeah.
Now I can say, well, I don't think that these processes are adequate. I think number 4 comes the closest. So let me take that, tweak the process a little bit, and then say, okay, now use this process to define the lesson plan. Now, if that process isn't fine-grained enough, you can say to ChatGPT or Claude, decompose this process into its sub-steps, and then the next level on, it's decomposed it further. Now you end up, instead of having a 3-step or 1-step process or a 5-step process, you now have a 20-step process because it's more fine-grained. And you say to it, okay, now use this process to systematically create the experience. And at that point, it'll be able to, so you don't even have to be completely aware of the best process.
Yeah.
You can actually have it suggest processes, refine processes, and then feed that back into a process-based prompt. And in that way, you know, when it's generating the lesson plan, if the output isn't right, you can go back and say, where in that process did it make a mistake?
Mm-hmm.
So that's what I mean by transparency. One, the process means it's steerable. So you know that the model isn't taking its best guess or using some irrelevant step. It's doing exactly what it is that you want, but because it's following the process and it's outputting it as part of that process, you can debug it. Because you can debug it, you know exactly what it's doing, it makes that whole process more reliable. So my biggest concern with people starting to use AI is that it's very much like the Wild West. You might have one person using a prompt and they're getting fantastic results. Another person is using it, but they're getting worse outcomes than they were before. And so you end up with this variable performance and quality. And ultimately, you actually reduce the overall quality of the work that teachers are doing. So that's my biggest concern with using recipes and outcomes-based approaches.
Yeah.
Also, one problem and this is probably the biggest point, is we need to guard against institutionalizing bad practices or mediocrity. So just because you can do something you've been doing 20 times faster, that's not necessarily a good idea. The moment you start getting AI to do it, it's going to start churning that out at scale.
Yeah.
And so all you're doing is you're putting an unnecessary cap on the quality they could have been.
Yeah.
So that's the biggest thing to guard against.
So it's almost, I always think that AI almost can emphasize the very best and the very worst. That it can you can amplify really good practice, but you could also potentially amplify really bad practice just because you can just do more of the same rubbish, basically, much faster. So that point about you asking the AI to tell you what it needs type thing, it almost feels like you're working in a metacognitive way. You're kind of working at a very different level where you're actually getting the AI to reason its thinking through and reason its process. Give me the 5 best ways to approach this and then choose one and then expand on it. So it's almost like you're elevating its thinking.
Absolutely. So this is something that the top researchers at Meta and Google have been exploring. They realized early on that by getting AI to reason first, it produces much better results.
Yeah.
So one technique that everybody needs to learn about eventually is chain of thought prompting.
Mm-hmm.
And then, of course, forest of thought prompting, and then, of course, chain of density prompting. These are technical terms. They'll make sense further down the line. But basically, these are just techniques to say, how do we get AI to break its reasoning down into a bunch of smaller steps so that it takes all of those reasoning steps, brings it into its own context so that it's more likely to produce a good output. So a lot of people are still at the end of their prompt saying, let's think about this step by step. So that signals to the AI that you don't want just an outcome, you want it to articulate its rationale.
Yeah.
But what's interesting is that has worked so well that OpenAI, Google, Anthropic, they've been building that into their fine-tuning. So now the model automatically does it without you having to say it.
Okay.
It's now, so you can still say it. It's perhaps a vestige in some cases. But what becomes more interesting is that when you start training or chaining prompts together, they've created frameworks that go beyond just one prompt, but rather create a system of prompts. So prompt 1 will say, make an observation. Prompt 2 is, what thoughts can you formulate about this observation? Prompt 3 is, okay, what action could you take based on this? Then take the action, make a new observation until it reaches the end. So that becomes an iterative process. And in doing so, possibly instead of using one prompt, you're using 7 prompts, but the output is significantly more reliable. You're getting maybe a 70% improvement on the quality of the output. Furthermore, there are techniques they're trying, and each of these techniques apply to human beings as well. It helps us reason better. There's another step called reflection. Essentially, you ask the model to address a problem, it produces an output. Then step 2, you say, reflect on what you've just done and identify everything that is wrong or subpar. Then what it does is it highlights those things and you say, okay, based on this, improve your response. And then that second attempt is going to be 25 to 30% better than the first in most cases they found. So also recognizing that a lot of what you're doing isn't necessarily trying to make one prompt succeed on its own, but that there are frameworks arising for how you chain them together to get much better outputs. And when you're building a product, often those intermediate steps form part of like a thinking scratchpad that the end user never sees. The end user only ever sees the final output. And so to them, they think, oh, what an incredibly clever AI I'm working with. But it's actually, they're seeing the output of possibly multiple models working together in concert. So I think in future, we're also going to be looking at quite an important, some people suggest that this is what GPT-4 already does. It's not one model. It's what they call what is it called again? Basically, it's a panel of experts. It's 11 different models, and there's one model that decides which model to use based on your query. So it's dynamically choosing the best out of 11 different. It's like a panel of experts or a mixture of experts. That's the term. MOE.
That's a fascinating way of looking at it, that actually what you're doing is you're working with not one model, and I think when we're prompting as well, that's a really great way, because we might call upon one particular expert through one prompt and then another particular expert. By giving the AI a role, it's almost like we're saying, okay, we're going to be focusing our attention more on this particular aspect of expertise of the model or that. So that's a great way of looking at it. Great way of looking at it. And the notion of chain of thought, I'd always kind of thought about this is that it's my thinking that I'm chaining, but actually what you seem to be suggesting here through sort of almost like metacognitive process, that actually it's the AI's thoughts, in inverted commas, that you're chaining together by think about this and then think about that and then consider this, that actually you're breaking the AI's thinking process down.
Absolutely. And interestingly enough, although you can create very complex instructions for an AI, it's always best to give it a small task to do. Mm-hmm. So essentially, think about the space it has to reason as being its context window. And its ability it reasons by generating language. And I use reasoning in quotation marks. It's just an anthropomorphization. But the more context you give it to reason, often the better quality the output. So for instance, if I give it the space to use 3,000 tokens for its reasoning, I can get significantly more complex outputs. But if I give it too many tasks to do in one go, what I end up with is diluting the amount of resources it can assign to that one task. So that's one of the issues I have with mega prompts, is that if you're asking it to do, so for instance, this is a good one. If you say, write a module, a learning module, and that's outcomes based, it's only going to have about 4,000 to 8,000 tokens to generate that. But if I say, start by creating an outline for the module, and then it has with sections. So then what it does is it creates the outline. Next, I say, okay, create section 1 as its separate one, as a separate core on its own. And I give it instructions for how I think section 1 should be crafted. It uses that full context and the full processing ability of that language model on that single task.
Yeah.
So you're going to get a much better result for the first section of your module. And you just keep repeating that. If you can use the API, you can chain those together. So essentially you say create a module, but then it will automatically run through all of those steps. But it will be 12 or 15 steps in reality. It's just you don't have to do them manually.
So it's interesting you mentioned there about the mega prompt and maybe not being so effective. Of course, Brian Romilly, who's kind of invented the notion really of the mega, or what he calls the super prompt, and he's done some quite interesting work in that. So, but you seem to be saying that. Do you think that maybe the models have moved on, and maybe these? Because I think he seemed to be the first person that was almost like jailbreaking these AI models. But do you think they've maybe moved on to the point where actually that's just not very effective anymore?
So I think, again, it's a matter of distinction. You can have a 5,000 word prompt that is incredibly effective. It's not necessarily that the prompt is long. It's how many different tasks you're asking it to perform.
Right.
And so with more powerful models, it can handle more tasks in one round. And that's a good thing. What's important to recognize is that sometimes you're going to get a much better result by having it focus on one task. It's similar to a human being multitasking. Some people claim that they're fantastically good at multitasking, and we can do 3 or 4 things quite fluently by shifting our attention quickly back and forth between tasks. But past a threshold, you start getting diminishing returns.
Yeah.
And so the sensitivity I'm trying to impart is recognize when it's not producing the level of output that you're looking for. At that point, you may want to consider decomposing the prompt so that you're giving more token resources and more model processing resources to a single task.
Understood. So that's again back to that notion of chaining prompts, that you actually one follows the other follows the other. I always find that when I'm teaching people like the absolute basics of prompting, I'm always saying start wide and narrow down. So like start broad, and then, for example, with lesson planning, give me the scheme of work for 10 weeks, and then give me the first week's lesson outlines, and then give me the first lesson, and then give me the minute by minute, and then give me the PowerPoint slide, and then give me the resources. And it's like I start broad, and that's a similar thing, isn't it? Because what you're doing is you're not saying give me the 10-week lesson scheme of work and the lesson plans, and because it just won't do that very well.
Exactly. Yeah. And also, the more you stuff into the context, the more, at least the models as they currently exist, lose the reasoning thread. They start to make mistakes in between because they're dividing too many resources. So absolutely, one useful heuristic I think that people can use is think about how a capable human being would tackle this task. How would an expert think about this?
Yeah.
And you're generally not going to go wrong by explicitly emulating that process with AI.
I think we can. Sorry, carry on, sir.
I think that's the last thing I will say. That I can speak all day about this, and there are more specific bits of advice. But one thing I can say is, I started creating a couple of videos on the subject months ago. I stopped sort of after about 3, but just watching those 3 will give you some idea of this compositional approach to prompt engineering.
Yeah.
Which I endorse.
But if you maybe send them my way, and what I'll do is I'll drop them into the show notes, and then people can access those. So look, I think we'll pause there. I think we could talk, and it may be that we can pick up maybe on another podcast, maybe to go a little bit deeper into some of the sort of the technical aspects that you're talking about. It would also be great. I'm trying to get Brian Romilly onto a podcast. Coordinating our diaries is just proving at the moment actually impossible. But it would be actually very, very interesting maybe to for the three of us to discuss this, because I think he obviously has a very interesting take on prompt engineering as well. So I think, look, thank you so much. Really, genuinely, I thought this was absolutely fascinating. I'm hoping that, like I've done, people who are listening will take on an awful lot of very useful advice. And I just think the more that we share these ideas, the more that we can essentially just improve our understanding of these models together. So thank you very, very much.
It's my pleasure, and thanks for having me here.
Okay, thanks. Bye.